good. Sorry about the interruption. Ran out of space on the iPad. We were just trying to undo B up here and identify what the monomers were, 72B. All right, now I'm going to start this thing right at the ester connection. So, yeah, the ester connection. So we know that the water molecule had to come out. We got to put the water molecule back on. So the OH goes on the acid. So that double bonded O carbon, we'll start with that, add the OH back to it. And then over here, the O, we have to add the H back to that. Yes? Now, what are these things attached to? The carbon with the double bond O, now what the acid is at the end, is attached to 2 carbons and then an oxygen. So let's go ahead and put that in there. That oxygen, what was it attached to?
O.
The way that you interpret these is you know that this is some repeating unit. You could take another one of these units and put it right over here so that this oxygen is connected to that, right? That's what it would be. Now, we're trying to undo this thing. It looks to me like that oxygen to that carbon is an ester connection again. We're trying to break those apart. So I still need to put the OH on that carbon and just an H on that oxygen. And that really is going to finish that molecule. Let's put an H back onto it. Now, for this side over here, the O, which I now have added an H back to, has 2 carbons on it. And then a C double bonded to O. And what is that attached to? Well, it's attached to this thing, which was an ester connection. So I'm undoing this thing. I have to put the OH back on. So you have to recognize what is the connection that's made, how was the bond made in the first place, and then undo it. Now, what do you notice about this and this? They're the same thing. You have a molecule with an acid on one end and an alcohol on the other end. And it can polymerize itself, as it just did. The alcohol on one side of the molecule reacts with the acid on the next molecule, and they come together. And then it still has an alcohol side that can react with the acid on the next molecule. This type of polymer is called a Homo Polymer because it's the same monomer repeating itself. It's a Homo Condensation Polymer. I'm going to leave this here, and let's go down to part C.
Wait, so what would that be called? That monomer?
I don't know what the name of that thing would be.
But like, what would it be since it has like 2?
We have an acid and, yeah, does it end with all or does it end with O acid?
Yeah.
I don't remember how to name these.
Well, that means that will be on the test.
I won't ask you to name it, no. But 72B might be on the test. Okay, the way where you have to do this, you have to identify what the monomer was to make the polymer. And part C. Let's do C. We decided that this is a condensation polymer. Yes? We have an amide connection right there. So we can undo an amide. We have to put a water molecule back on. The OH is going to go on the acid, and the H is going to go back on the nitrogen. Yeah? Okay. So I'll do the nitrogen on the left of that amide side. We have N. It had an H on it, and now I'm going to add another H to it. I'm talking about this N right here. And I got to put the water molecule back on, and the H from the water goes on that N, and it's attached to 2 CH2s. So I'm going back like this, and then that left CH2 is attached to another N. That N is now hooked up with another C double bond O, which needs to be broken. So I'm going to put another water molecule on that. And so we have a diamine. Yes, Solon?
In this type of condensation reaction, 2 molecules of H2O are released when 2 molecules of react.
Yes. Yes, that's right.
So like
Every time the connection is made, a water comes
before
up.
it was like 1 for everything, now it is 2. Like,
Oh, well, no, not really. Every connection, one water molecule comes up. There, a water molecule comes up. And to make the next connection, a water molecule has to come off of there too. And over there, a water comes off. So every time the amide forms, a water's taken out. Okay. So the diamine is one of my monomers, but I'm not done yet because I also have, and what if we can hopefully see this, it's going to be a diacid. Is my other monomer molecule. We have a C double bond O, and OH is going to go on that end, and OH is going to go on that end. These, to me, are hard problems. If you don't have trouble with these, I'm going to be impressed. Those are our two monomers. The Zoom dolls, go ahead, Trina.
For this kind of like polymer one, they're always going to be like both sides, like the di, whatever.
You mean like diacid?
Yeah, diacid and di.
Ask me a question again. For condensation polymers?
Yeah.
No, because this condensation polymer in part B, we didn't have a diacid and a dialcohol. We had one molecule in which one side of it had an acid and one side had an alcohol.
But like if it was an acid and an alcohol, it would always be like where both sides have either H or both.
Yes. Yep. So this one up here, since it was the same molecule repeating, it's called a Homo Polymer, where we have two different molecules and they alternate, diamine, diacid, diamine, diacid. That's called a copolymer. You'll see those terms. In fact, at the end of 72, it says which ones are copolymers. Well, part C is a copolymer. I've got about 6 minutes or whatever left. I wanted to show you another. Let me just show you this one. We don't have a whole lot of time to do it because I want to introduce the lab. The Zoom dolls do have a streak of nasty. And you're going to have to just understand that they're not happy unless they've really tried to stretch you out. Look at 77 at the top. It says polyimides are polymers that are tough and stable at temperatures of up to 400 degrees. They are also used as a protective coating on the quartz fibers used in fiber optics. That's interesting. You're going to find this here. I love the Zoom dolls. You know how I feel about them already. I love them. They're great authors. But they're so easy to make fun of. And so many of these problems are going to give you like the biography of the molecule. And you look it down here. The Amoco Chemical Company has successfully raised the odds. Who cares? Just give me the problem, right? But they don't. They love to just give you
They make it like
the whole story.
problems where they get all this information in your head.
Yeah.
Like, what am I supposed to do?
Yeah, that's right. That's right.
It's
Yep.
like the ACT science.
But yeah, you can ignore that part. Yeah. Sometimes, I mean, they'll give you like that much history of the molecule, and then they'll, you know, one sentence will be like, okay, how much is 5 grams? How many molecules or whatever? So, and they're just fun. They're cute. But look at this thing. What was this made of? See, I'm telling you, they can be nasty. Now, yes, it is. Very good eye. What do we have right here? Looks like it's an amide connection. We can undo an amide. But this is weird because it turns out that this one nitrogen is making 2 amides, isn't it? One with the top carbon and one with the bottom carbon. So we're going to have to add 2 hydrogens back to the end and a hydroxide here, not a hydroxide, OH here and OH here. And then the same thing over on this side. Amide, amide. So we're going to have to add an OH back there, and 2 H's to the S. So, yeah, they do that stuff. What? No, you'll have to look in the solution manual only because I don't have enough time. I at least wanted to show you what we're doing in the lab.
There's a video so you can see how to solve the problem.
Yeah. Go back and watch that. Last thing, with only a couple minutes left. In our lab, we're going to do both a condensation polymer and an addition polymer. The condensation polymer is going to be this one. I hope you can recognize this compound. What would you call this type of compound? Thank you. A diamine. It's a diamine. Right. An amine group on the left and one on the right.
Oh.
That was where you were going with that, right? Over here, what do you expect a diamine to react with? A diacid, right? But that's not a diacid. It kind of looks like it could be a diacid. But instead of having OH on the end, it's got Cl. The reason? Diacids are very expensive. This thing alone is expensive. And diacids are more than that. I just have to tell you because it's hilarious. 100 milliliters of this stuff. We buy it in a 100 milliliter bottle. Like literally, it's like that big. 100 milliliters is less than a third of a pop can. Pop cans are $3.55. This is 100 ml. $160 for this. For 100 milliliters.
Do we each use like one drop?
How much is that?
So we make a dilute solution of it so that everybody can use it.
How much is it a diacid?
I don't know how much diacids are, but we buy this because it's cheaper than diacids.
That's still.
Oh, so it's surrounded by other
So-
things to make it.
And it does not have a nice smell either. I'm going to leave it out in the room, and you're going to smell it, and you'll know. But you have to smell it. That's chemistry. So anyway, what type of polymer are we expecting to be made here? A
No, no.
polyester. I'm sorry.
No,
I
it's not.
repeat what you said. It's polyamide.
Polyamide.
Because we're going to have a C double bond O to an N.
Yeah.
So these are going to come together. Rather than getting water as our small molecule that's condensed
HCl.
out, it's going to be HCl. So we'll add sodium hydroxide to neutralize it when it's made. And it's going to just be a typical, it's going to be nylon. And the way it comes out is awesome. I'll show it to you on Monday. This is our other polymer we're going to make. What type of polymer do you expect here? Condensation or addition?
Condensation.
Because at the end of the
Look at that thing right there.
Double bond. Unsaturated.
That's unsaturated. It's going to make an addition polymer.
All of it?
Addition.
But it's an ester
If
or something.
You see double bond O and
it does look like an ester already, and it is an ester. However, the presence of the C double bond to C makes that thing subject to being
When it's in the parent.
hit by radiation. When it's in the parent, if you have like carbon, double bond to a carbon in the parent, then think addition.
O is double bonded.
Yes, right.
so this is an addition, not
Okay,
a condensation.
just before you turn this off, I would like to thank this guy right here for taking care of the video work. Thank you.